Hey everybody, this is chapter 1 in geometry, and we're actually going to, in our book, in our note packets, we're going to start with section 2. So um, there's a lot of vocabulary here, and what I'm going to do is I'm going to pull the vocabulary out. I'm going to have you write it down, so if you could write the name of the vocabulary word or the word down, um, like for point, going to go ahead and write that down, and then I'll pull out off to the side here. I'll pull out what the definition is. And I think what I'll do is I'll pull them all out first, and just you guys, once I get them all out, you guys hit pause and write them down, please, and then I'll go back over them a little bit, and I'll add some notes to that for you. Okay. So the first one is point, and then we have line. We have a line segment. We have something called a ray. We have opposite rays. We have something called a plane, and this will not be the kind you get on and travel somewhere. We have collinear points. We have coplanar points. And we have intersect. Okay, so they're all up. Hopefully you can see them all here. Uh, if you want to go hit pause, I'm going to hit pause anyways, but if you guys want to hit pause, take some time to write it down, and then when you're done writing them down, you could hit play again. You're ready to go. Okay, so hopefully you got all those definitions written down. So what I'm going to do here is just kind of draw a picture for each one of you, just to kind of illustrate what it's trying to say. Okay, so a point is just a place in space, and it doesn't really have a dimension. It's indicating where something's at. And then typically we use letters to signify it, because you could have more than one point. So we want to make sure you know which one to look at. So typically it's going to be a capital letter kind of hanging out next to it. I'll put an A there, okay? A line is one dimensional, just means that it's flat. So the line's going to be like that, but that's a symbol technically for something else too. So to say a line is a line, I need to put arrows on it, and that really just tells me that line goes on infinitely in both directions. Okay, so a line is going to be a little bit different than the next definition you have. A line segment is, once again, it's flat, it's one dimensional, but a line segment's finite. It has end points to it. It stops at both ends of it. So we're going to put these little points on it, and I'm going to be able to label it. I'll just use the two capital letters A and B most of the time. Okay, so that's a line segment, different from the previous one, a line. Now, one thing I want to just mention here is that a line and a line segment is really made up of a bunch of points. So going back to a line, it has points on it, but I'm also indicating this line goes on forever. So I could have a line having points, but I could have a line segment having points. The difference being that in a line, it goes on forever, but in a line segment, it's finite, it stops. Okay, so when we ask you to look at things, when we talk about a line, we'll have this symbol, and below it we will write down 2 points that might be on that line. Now, like I said, it's made up of really literally infinite number of points, but I need to indicate at least 2 just to say, hey, look at that line. Okay, a line segment will just have this little symbol like this with the 2 endpoints labeled below it. Okay, so these are things right here that we need to kind of understand what they mean to us. Very similar, mostly because they use the same letters, but things so that we have to know what we're talking about. like on a test or a homework assignment. What are you asking me to look at? Well, that's how I tell you, okay? Next definition's array. Array is going to have an endpoint and then go in one particular direction infinitely, okay? So I drew it to the right. It could go vertically up, vertically down. It could go left. It could go diagonally. I'm just showing you, kind of a universal one here. But because it has an endpoint, or they call it an initial point or the starting point, we have to label it. So I'll label it with A. Now, same thing with array. It's made up of a bunch of different points. So there's other points on this thing going in that particular direction, whichever way it's going. And I can label another point. So when I need to say, hey, go look at this ray that I'm talking about, this is going to be the symbol for it, and I need to give you the endpoint first, and then some other point that's on it. Okay, so that's the symbol for ray, and I'll call it ray AB, so I know which one to look at. Okay. All right, opposite rays are going to be something that really kind of tells you in the definition. They go in opposite directions, and they form a line. So you're going to have, it's going to start here. Both of them start there, but they go in absolute opposite directions. So this might be A, and then B might be over here, and maybe C's over there. Well, now which ray are you talking about, Mr. Kasich? Well, I want you to look at ray AC. Well, that means, okay, then I'm going to look at this part over here, okay? Later on, I might say, okay, now look at ray AB. Well, that's this one over here, but together they make a line. So really important that you know that opposite rays form a line, okay? A plane is a two-dimensional figure. It means it's got a top and a bottom, basically. If you look down here, the bottom of your notes, on my screen and your screen, hopefully it's green, but I think in your note packet it's kind of black and white. But a plane would be just like a flat piece of paper. It's got a top and it's got a bottom. It doesn't really have technically any sides. Also, you might think of your desk or a tabletop as also a plane. So any flat surface is going to be a plane, okay? A plane is going to be defined by points that are on it or points that are at the corners, okay? So it really kind of depends on what you're given, right? And when you talk about a plane, it's really, this gets confusing for some students. Planes are going to be determined by at least 3 points that are either at the corners or on the plane. So I put A, B, C, D, or let me do this. I forgot about that one. I'll put Z down here because Z's not there. The D was already on the plane, okay? So I need to just have 3 points to identify a plane, or 3 corners. That's what I kind of like to look at. 3 corners to name a plane. So if I use these 4 corners that I have, I could call it ABC, plane ABC, plane BC, Z if I wanted to, plane BAZ. You need 3 points to kind of, so I can kind of visualize, well, what plane are you talking about? Because we'll see later on, you get multiple planes, and I need to be specific which one are you talking about, okay? All right, next definition is collinear points. Points that are on the same line, segment, or ray. So collinear means they're all on the same. So if you went back up to this ray that I had up here that I showed you, the opposite rays, it's made up of points A, B, and C, or ones that I kind of showed you. So those are collinear. They laid on the same line. All right. Typically 2 points are going to lie on the same line, because you could draw a line between any 2 points that exist. So 2 points are always going to be collinear. Sometimes we're asking you for like 3 or 4, okay? But they could lie on the same line, the segment, or array. So those definitions that we had earlier. Coplanar points are points that lie on the same plane. So if you look at this in our video here, G, D, E, and F all lie on the same plane. Okay. Also, A, B, C, and Z, the ones I put on there, all lie on the same plane, so they're coplanar. All right. If you look at H is not lying on that plane, so it's not coplanar with those other ones. Okay. So there's a lot of definitions, a lot of vocab. You need to study that. That's part of what you need to do to understand this. Okay. Got some examples down here to kind of go through these definitions and kind of practice it a little bit. Name 3 collinear points. So this could have more than one answer. It could have just one answer, but 3 collinear points, points that all lie on the same line. So I'll let you take a look at that for a sec, and then we'll look at that. So 3 have to be on the same line. I think the only answer we have is D, E, and F are all lying on the same line, so therefore they're collinear. Name 4 coplanar points. So just use the ones that we gave you on the note packet or in this video. Ignore A, B, C, and Z for a second. 4 coplanar points. So 4 points on the same plane. I'll let you kind of look at that. And that would be D, E, F, and G are all coplanar. D, E, F, and G. Okay. They all lie on the same plane. Not necessarily on the same line. They didn't ask me that. They said coplanar. Okay. Now name 3 points that aren't collinear. And this one actually has more than one answer. And let's take H. H has been sitting up there and we're ignoring it. H would be not collinear with F. It's not collinear with G. It's not collinear with D. So that helps us a little bit. So I could say H and D, let's say, and then one other point. Now I'm gonna say E. You could have said something else. You could have said F or G. I'll say E. Now, a lot of you guys will go, wait a minute, D and E are on the same line, but the question said name 3 points that aren't collinear. Those 3 points don't all lie on the same line. So you could have had a couple of different correct answers, okay? All right, let's move on here. If you're watching this video and you're having to learn it watching the video, make sure you write down questions, get them to me somehow. Maybe the next time we see each other, or email it to me, and I'll try to answer those. But you should always write questions down off to the side if you're not really getting it, okay? In B, it says draw 3 non-collinear points, J, K, and L. So 3 non-collinear points. So I'm just going to put 3 points out here, and not on the same line technically, J, and label them K and L. Okay, and then draw line. So we're coming over here using those symbols that are above there that I showed you a little bit earlier. Draw line J, K. So put arrowheads on the ends. Then the next one says draw line segment KL. So there was no arrows on it, so that means a segment. So it has endpoints at K and L. And then draw a ray. There's a little arrow on that one end. Draw ray LJ. Okay. So those 3 points were not collinear together. And then what did we get? Well, technically we got a triangle. Okay. So really just an exercise in understanding the symbols, being able to draw those particular segment lines or rays, and we form something out of that. Okay. All right. Let's move on. Okay, this is a little matching game. It's not in your note packet, so it's just right here. So kind of do this with you. We're going to take the definition on the left and come over here and look on the right. We're going to pull hopefully the right definition to match it up with with the definition and the name of it, okay? So a finite portion of the line. So finite, remember, that means that it stops. There's a beginning and an end. So if you go kind of flip back through your notes, you might be able to figure this one out. I'm going to make a guess, okay? I don't know all the answers, but I'm going to think a finite portion of a line is a segment. Okay, an accepted rule, we really didn't talk about this, but it is something that we'll see a little bit later on. I'll just kind of give this one to you. An accepted rule is a postulate. And we're going to learn later on there's postulates and axioms and definitions. There'll be other rules that we have to know, okay? Something that extends in one dimension. I'm not really sure about that one. Extends in one dimension. I'm going to go, that's got to be a line. That which has no dimension. So that was kind of tricky, but I think that's a point. Really, really loud instruments. That was not part of our definitions, but I'm going to guess it's a bagpipe. Right. Extends in two dimensions. I think that was a plane. And then the last one, obviously, I hope, is a ray. An initial point extending in one direction. I think that's correct. So let's check and see if I was right. We were. Okay, so just a little kind of practice. Okay, let's move on here. Section 1.3, segments and their measures. So axiom and postulates, we kind of did that in a little matching game before, but a couple definitions here, okay? So axioms and postulates are rules assumed to be true. So we do that a lot in geometry, especially in a couple chapters. We do stuff called proofs, and we need these rules that we are assuming they're true, and we do a lot of showing that they are true. Okay. Congruent segments that are the same length. So congruent just means that they're equal, and so a lot of times you're going to see this symbol that usually means congruent to. And then got this one ruler postulate. So there's a couple blanks in here. I'll just open those up for you and let you kind of add those in. So really the key here is absolute value. You guys might have remembered absolute value from Algebra 1. We had these like bars here. We put a negative number in here, but remember the absolute value of -5 is +5. And that's really talking about distance. So if you're looking at it, they call this the ruler postulate, but this is really kind of like the number line. That the distance between A and B is always going to be a positive number. Even if I went from B to A, I'm still going in a positive direction. Okay, so it's not a really big deal here, but just something to kind of understand. We're going to talk about distance a lot. It's always positive. Okay. Next one is segment addition postulate. This one really, for some reason, screws students up. I'm not really sure why, but it's just saying up here in the postulate, if B is between A and C, then the segment AB plus the segment BC would equal the whole distance between A and C. So that seems pretty simple, but we get this one really confused. I'm not sure why. So let's make sure we can break that bad habit and make this a little bit easier, okay? We're going to go here and use this number line. I want you to kind of look at what's the distance or length of each segment. So we're looking from A to B. Now remember, that's a positive number between A and B. I could count 1, 2, 3. So the length of line segment AB is 3. from B to C, then you could count how far are they away. Now just make it simple. Count how far is it. I'll let you guys do number 2 and do number 3. So for number 2, from B to C is 1, 2, 3, 4, 5. And then from A to C is 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Okay. But if you use that postulate up there, you know, from A to B was between B and C, or B was between A and C. So therefore, I could have taken my different segments and added them together, and I should have got what the whole thing was. Okay. So that's a big topic right there. That one's going to get used a lot, and some algebra is going to get thrown into you. We'll see that in a little bit, but we got to make sure we get that one down. Right? I could take two segments, they're kind of linked together. I can squish it together and get the whole thing. So make sure we're doing a good job with that. Okay. All right. So for example number 2, use the number line below to tell if the segments are congruent. Now remember, congruent means basically that they're equal or the same. Okay, so I'm going to let you guys kind of do this one on your own, and then I'll check it with you, and then we'll do number 3 together because that's pretty important. All right, so go ahead. If you want to hit pause and do questions 1, 2, and 3. Okay, so if you're back from G to H, just counting here, going by ones, 1, 2, 3, 4. From G to H, from H to I is 1, 2, 3, 4. So yes, they're congruent. From G to H, well, G to H was already 4. From I to K, I is 1, 2, 3, 4. So they are both the same or congruent. From H to J, so that's going to be 1, 2, 3, 4, 5, 6. From I to K is 1, 2, 3, 4. So that would be a big fat no, they're not the same. Okay. So just count. Kids miss this question. I'm not sure why. They look at stuff and they just go, I think it is, know it. It didn't take us very long to count. Okay. All right, taking that addition, segment addition postulate, one thing I want to do before we get going here too, you see these little lines right here? I call them hash marks. They're congruency marks. But when in math, and especially in geometry, when we're looking at figures or dimensional figures, things like that, those little hash marks mean that this thing is congruent to that other thing that has the same mark. Okay, so these have the same mark. So that means that this is equal or congruent to that. All right. So technically, what I could say then, since they got endpoints here, I could say that ST is congruent to TU, and that's going to help me a little bit here. Okay. So we haven't really discussed what those are. Some of you guys might know what it means, but now hopefully everybody knows that, remembers that you're going to see it a lot. Okay, it just means that this is equal to that. So given that, I come back to my question, and ST is 3x plus 3, and TU is 2x plus 9. Well, if we go back to this thing that I just talked to you about, well, I can set them equal to each other. So ST is equal to TU, but ST now is 3x plus 3, and TU is 2x plus 9. So this is a lot what you're going to get in geometry, is taking this algebra that you should know and applying it. And in this case, I'm using substitution to be able to do that. So I want to solve this for x, because they want me to get the value of ST. Well, I got to get x first. Okay. So I'm gonna subtract 2x from both sides, and then I'm gonna subtract 3 from both sides, and that's going to get me x is equal to 6. Okay. Now, I got to be careful here because I got x equals 6 and everybody thinks I'm done. The question was, what is ST? Well, ST is represented by 3x plus 3, so that means I got to go plug it back in. Okay, so I'm going to take that 6, plug it back in for x, so 3 times x, or 3 times 6, plus 3. So 3 times 6 is 18. 18 plus 3 is 21. So that's what ST is. Okay. Then they go, well, what's the value of TU? Well, TU is represented by 2x plus 9. Okay. So I need to go plug that back in. Now before I do that, let me just remind you, they are saying with these little hash marks here that those two things are the same. Well, if I'm thinking, well, I set this up, TU's got to be 21 because it has to be the same as ST. But unfortunately, in geometry, we do a lot of things called proofs. We have to prove it. So once again, I go back up here. X is 6, so I'm going to substitute 6 in for x, and in the 2x plus 9, that's going to 2 times 6 is going to give me 12, and 12 plus 9 gets me 21. So what I just did was I proved that what we got for x was correct because it made both those segments congruent. Okay. Last question, what is the name of point T? We haven't really talked about that yet. We have, but I'm going to assume, is T really like in the middle of S and U, the two endpoints? And it must be because it split it into equal halves. Okay, so the name that we're going to get is called a midpoint. Okay, which we'll talk about. But I'm going to give you another name that you're going to hear a lot too. For other things, it's going to be called a bisector. Okay, and a bisector, that's its definition, it cuts something into equal halves. In this case, it happened to be a line segment. Okay. All right, an example 4, got to be careful here. One, I hope you understand that Q really is not in the middle of P and R. For one, it doesn't look like it, and two, they didn't put these little hash marks in like they did in the last question. If they did, then it tells me it is, but they didn't. Okay, so I'll get rid of those. So they're not in, or Q is not in the middle, so I can't say that like PQ is equal to QR. But I could say this, so if you could write this down, PQ plus QR is going to be equal to PR. And that's the segment addition postulate that you got a little while ago. So let's have that off to the side. I can say that. I have a rule that says I can say it, so I did it kind of mathematically here for you guys, okay? So if I did that, they tell me in question A, PQ is 7 and QR is 10, then what is PR? Well, I've got PQ right here, and they're telling me it's 7. I got QR right here, and they're telling me that it's 10, and that should equal PR. Okay, so that's a question that, you know, we should understand what the rule is telling us I could do, so I'm going to do what it tells me. I think this is a pretty easy problem, all right? So PR, 7 plus 10, is going to get me 17, okay? All right, so we did that one for you. So why don't you guys try B and C. If you want to hit pause and try those two, and then we'll come back and we'll check our work, okay? Okay, so all they did was they've changed some of the values here for the same question we just did. PQ is now 20, QR is now 22, and they want PR again, but this is going to be different, okay? All right, so, and write this stuff out. Don't do this stuff in your head. You should practice writing it down. It's really important for math. I know a lot of you could do this in your head, but later on it gets a little bit more difficult that we do stuff backwards. Get used to writing stuff down. So 20 plus 22, I think that gets me 42 for PR. Okay. Now using the same one, they're gonna think we're gonna get lazy here. Make sure you read this. If PR is 25 and PQ is 10, then what's QR? Well, taking that same one, substitute what they gave me. They gave me PQ. They told me it's 12, but they didn't give me QR. That's what they want me to get. And then they tell me that PR is 25. That's what they want me to get in the other two questions. So write it down. Once again, that's a pretty easy question. If I subtract 12 from both sides, I think I get QR is 13. Okay, so those are questions you'll get on a test. Should not be that hard, but we want to make sure we write stuff down at least and see it and work towards perfection, especially when it's, I think, pretty easy. Okay. All right, section 1.4. This is angles and their measures. This lot of definitions here again, so what I'll do is I'll pull all these out, and then you guys can hit pause and write them all down, and then I'm going to draw some pictures that go with it. There's a lot here, and they're all really important, and then we'll do some rules that go with it. Okay, so pull these out. An angle, an acute angle. So some of these other ones go, they're angles, but we then classify angles by certain things. A right angle, an obtuse angle, a straight angle, an adjacent angle, vertex, and congruent angles. Okay, so if you want to hit pause, I'm going to hit pause for a second too, catch my breath. Go ahead and write those down, and I'll kind of go over some of this stuff with you in a second. Okay. Okay, so let's go over some of these definitions. I'm going to draw some pictures off to the side, so if you can go ahead and do that, and hopefully we'll make all this seem somewhat relevant. If you remember too, if you got questions, write them down. Okay, and an angle is two rays with the same initial point. So if you remember, a ray had like an end point, and then it went in one direction. So I'm going to draw a ray. Okay, and that point was either called an end point or a starting point, or in this case, they're using the word initial point. And it's two rays with the same initial point. So I'm going to go that same point, but draw another ray. And that's what creates an angle. Okay. So an angle is going to look something like that. It could look like a bunch of different stuff. If you guys remember, opposite rays kind of did this. Well, that technically is an angle. Okay, remember they said it made a line, but it's also making an angle. Okay, and then you'll see some other angles drawn kind of the same way, but you'll notice that it's got the arrowheads on the, showing which direction to go. So you need to make sure you include that. Okay, an acute angle is an angle that's going to have a measure of 90 degrees, less than 90 degrees. Okay, it's going to be bigger than the 0, because that really doesn't exist, but it is going to be less than 90. So let me go back and talk about this, how an angle is labeled. The letter M stands for the word measure. In this case, the measure of an angle is in degrees. Okay, and then when this symbol right here represents the word angle. So measure, angle. Then I got to tell you which angle. So there's a couple different ways I'm going to do that. In this case, I'm going to talk about angle A. Okay. What do you mean angle A? Where is that? Well, an angle can be named by a letter where that initial point is where the two rays met. Okay, so that's one way I could do it. Sometimes I get a bunch of different angles, and you need to be really specific, Mr. Kaznick. I need to know which one you're talking about. So sometimes I have to give you points that are on those rays, okay, along with the initial point letter, okay? That's another definition a little bit later. I'll just say it now. That's a vertex where those two met. So when I say, you know, angle, and I got to be a little bit more specific, I'm going to say look at angle BAC. So BAC, right? That vertex or the initial point has to go in the middle of the other 2 points. Okay, so that's going to be really important for us to understand how to write it and how to be able to identify it. So I might say, what's the measure of angle BAC? And then we'll do some math or something to figure that out. Okay. All right, a right angle is going to be an angle that has a measure of 90 degrees. So that's going to look something like this. Okay. And we're going to, that initial point where those two rays met is going to be called A. Okay. So let me kind of go backwards for just a sec. An acute angle had a measure of less than 90 degrees. So an acute angle, if this one's right, I'm going to abbreviate, that one's right, an acute angle has to open less than that, whatever it might be. That's 90 degrees, well, an acute angle might be 89 degrees. But an acute angle is going to have an opening that's going to be less than 90, okay? So those two kind of go together there. And then the next one that kind of goes with it is obtuse. So an obtuse angle is going to have a measure that's going to be between 90 and 180. It's not going to be 90 because that's a right angle, and it's not going to be 180 because that's a different angle. So it's got to be somewhere in between. So an obtuse angle has to actually open bigger than what a right angle is. So that might look something like this. Okay. That's going to be bigger than 90. Okay, so this one's acute, and this one's obtuse. Remember, that acute angle could look a little bit different. This obtuse angle could look a little bit different, but it's how they open in relationship to a right angle. Okay? A straight angle is going to have an actual measure of exactly 180 degrees. So a straight angle is actually going to look like this, and that's a line. Or in this case, we'll call it a straight angle because we're talking about angles at this point. But its measure is 180 degrees. So I want to take a little side step here. A line is an angle, and a line has a measure of 180. That's something that we use a little bit later. Okay. A vertex, or I'm sorry, adjacent, two angles that share a side. Adjacent means next to. Adjacent's another term that will be used a lot in geometry, so we need to have that down. It means it's next to something. In this case, what it's saying is that there's an angle, and I could then draw this line in between them. What I've done now is created two angles. I've got this one, and I've got that one now. Those two angles are next to each other because they share that side, okay, or that ray. So two angles that are next to each other share a ray that allows them to be called adjacent. Okay. A vertex, and I talked about that earlier up here. A vertex is the initial point of an angle, so it's where two rays meet to form an angle. So that's a vertex. And you can label label it with letters, but vertex is going to be really important for us to remember what that's called. Okay. Congruent angles, we learned what congruent meant last section. Congruent angles are just angles with the same measure. Okay. All right, so a lot of vocab there. Hopefully you got it all down. If you're not sure about it, make sure you're studying it. Please make sure too that you're asking questions. All right. All right, next postulate that we have here in the box is called the angle addition postulate. This is a kind of the same thing we did with the segment addition postulate. If I have two things and add them together, I get something bigger, okay? R, S, T is this angle they're asking about, and they're telling me that P is inside of it. So what we did was from here to here, we drew a ray, and we got from S to P is just showing that P is in between R and T, okay? So what I had was, first off, I had this angle RST, S was the vertex, okay? R and T are points on the rays. But when I put P inside, what I did now was I created two more angles. I created angle R, S, P, and I created angle P, S, T, okay? And by doing that, I can now say I can add these two together. That's what addition means. I can add those two small angles together to help me get the big one, RST. So we did that with the ruler and the segment addition postulate last section. So it's just saying the same thing. I can add two things together, I get something bigger, okay? So we'll kind of look at that and practice that. This is another one of those things we use a lot. To me, it's okay, that's pretty easy, I get it, but we kind of mess it up. So let's work hard on understanding that. Okay. We're going to go ahead and name some of these angles. We got the words up here and above them. Okay, I think for you guys on your packets, a little bit different. So we got the terms acute, obtuse, right, and straight. Okay, and we're going to look at A, B, C, and D and hopefully label them. Now remember, all these other terms are kind of, they come off of what a right angle is. So this one, to me, A, it looks like it's right. Typically, if we know that it's right, there's a little box there. I guess they didn't want us to work or make a really good guess at this, but and I don't like guessing in math. Math is pretty black and white. There's no gray area, okay? But I'm going to assume that that one's right. So I'm going to call this one right. And then remember, acute and obtuse means how it opens in relationship to that. So for B, it looks to me like it opens less than 90. So that would be an acute angle. In C, that looks like it opens bigger than 90. So that probably, if I go back to my definitions, I think that's obtuse. And then D looks like it's a line. If we remember, a line's also called a straight angle. Okay. All right. So there you go on that. All right. So what we're going to do here is we've got a graph and we got some points. Remember, this is the X value, this is the Y value. We got an X axis, we got a Y axis. So let's plot these points. So 0.32 is 3 on the X axis, -2 for Y. So I go over 3 and down 2 from the origin. And that's A. I'm going to label it. B is 5, -1, so X is 5. And Y is -1, and that's B. And then C is 5, 2, 5, -2. So that's right there, okay? So it's an angle right there, but they're not telling me like what's it supposed to look like? Remember an angle would have been like ABC or some variation of that. And remember that would be the vertex. So I'm just going to take ABC like that. So I'm going to draw my angle with B being the vertex. So this would be my angle. Okay. And they would, let's name this. Is this acute, right, obtuse, or straight? Well, to me, it's not straight for sure. Doesn't look like it's 90. And it looks like it's opening less than 90. So I think this is probably going to be acute. Okay. Hopefully that makes a little bit of sense for you. Okay. Okay. So once again, if you do have any questions, write them down, and somehow let's get together and talk about it. Okay. All right. For these, they want us to find the angles. So they want us to find the bigger angles. So like you want to find angle ABC. So that ABC is really made up of this angle and this angle. How do I find that? Well, we have this rule that says I can add the smaller ones together to get the bigger ones. Okay. So 62 plus 34, I think that's 96 degrees. Okay. Sometimes my math isn't very good. You got to tell me. Once again, there's these two angles. There's this angle here and this angle here. They're sharing this ray, so they're adjacent. Remember that term? So I think I can add these together to get the bigger angle. The bigger angle is really a line, and 125 plus 55 is 180 degrees. So remember, a line or a straight angle. Oh my gosh, sorry, my writing's not very good down here at the bottom. My writing's not very good, period. So two terms mean the same thing when it's something's 180 degrees, okay? C, I got this big angle right here, so I've got this one ray in there that makes these adjacent. So once again, I think I could add these together, and when I add them together, I think I get 184. Okay, and 184 degrees. I hope that's right. Give me a hint here. I don't know what my hint is. What's my hint? Get rid of that. Hint. No, it's not. 143 they're showing me it's the whole thing. Okay. So what they really want me to do is they want me to get this little angle in here. How do you think I'm going to do that? Well, I think then if the whole thing's 143, I think I could subtract 41. And that would get me 102 for this one up here. Okay, so 102 is really from here to there. Okay, so sometimes you got to look at the hint, see what's going on. I don't think you had that in your notes. Okay, so 102 really is the answer for this question right there. Okay, so I guess I should look at it before I do it. Okay. Okay, we got another little quiz here. We got angle measures down here at the bottom, and we have acute here and obtuse here, and we have some angles that I can't call either one of those, so we'll put them in the neither. Okay. So remember acute, let's just write this down. So remember acute is going to be less than 90 degrees. Obtuse is going to be greater than 90 degrees. Okay. All right. And neither is going to be something that doesn't fit. So 180 degrees, that's greater than 90. But remember 180, I think it had a definition. I think that was called a line or a straight angle. So I think I'm going to put it over here in neither. My next one is 90.1. So if I look at my things, see it's less than 90, 90.1 is actually bigger than 90. I think it fits over here with obtuse, so let's go there. I have one that's 90 degrees. Well, 90 degrees is not less than 90, and it's not greater than 90. So remember, I think 90 was right. So in this case, it's probably going to be neither. The next one's 176. So I'm going to look at these, and I think that's going to go over here on obtuse. It's bigger than 90. Okay. 45 degrees is the next one. 45 degrees is less than 90, so I think it's acute. 0, I think we talked about that. Nothing can really have a measure of 0 degrees and still be called an angle, so I think that's going to be neither. The next one I have here is 181. Now, that would fit. It's greater than 90, so it'd be obtuse, but we really were talking about stuff that was 180 or less, so I'm going to put that in neither. Okay. 100 degrees, if I go back to my definitions, 100 degrees I think would be obtuse because it's greater than 90. 37, if I look at my definitions, I think that's going to fit with acute because it's less than 90. 1 degree, well, it's got a measure, and it's less than 90, so I think it's going to go here with acute. 89. Pretty close to 90, so is it right? Well, if it's right, it's got to be 90. So it's less than 90, so I'm going to call it acute. 179.9, that's going to be greater than 90, but it's also less than 180, so it's not a whole line. So I think it's going to go there. 131 is also greater than 90, so I think it's going to go here. 17 is less than 90, so we'll call it acute. 91 is greater than 90, so that would be obtuse. And then 89.9, that's also not exactly 90 degrees, so it has to be less than 90, so I think it's going to be acute. So let's see if I'm right on all these. I'll check it. All green check marks, so I think we did good there, okay? So just being able to categorize angles by their names, and that's by what their measure might be, okay? All in relationship to 90, so hopefully you got that down, okay? All right, section 1.5 is talking about angle pairs. So pairs means two. So vertical angles, angles on opposite sides of an X, a linear pair, two adjacent angles that form a straight line, complementary angles, two angles that add to 90, and supplementary angles, two angles that add to 180. So really important here. So really topics that we use a lot throughout geometry, and sometimes we get away from them for a while, then they kind of come back, and then we got to remember what they all mean. So it's really important you study these and get these down. Not really difficult stuff, but then we throw some algebra at it. So you really got to understand these rules pretty good. Vertical angles are angles on opposite sides of an X. So let's just say I drew a line. Get my pen going here. Drew a line. Show my arrows, it goes infinitely, but then I draw another line to create something that looks like an X, okay? So that's where that comes from. Angles on opposite sides of an X. So this angle right here is opposite this angle right here. And what it doesn't tell us, it doesn't tell us that vertical angles are also congruent. So if you want to write that down, they're going to be equal. So remember what this little hash mark means. It means they're equal, okay? Now, those two are vertical, and vertical means up and down. But in this case, vertical doesn't always mean up and down. These two angles are also called vertical angles. They're on opposite sides of the X, which kind of follows the definition. So those two angles are on opposite sides of the x. They're called vertical, and they also will be congruent. Now I'm putting two little hash marks here so I can differentiate between the two different kinds of angles that I got, because they're not all going to be the same, typically. They could all be 90, but that doesn't happen very often, okay? All right, so those are vertical angles, but we got to remember that vertical angles, the ones opposite each other, are always going to be congruent also. A linear pair are two adjacent angles that form a straight line. So first off, I'm going to draw a straight line. And adjacent means that they share a ray or a side. So this angle right here and this angle right here share a side. And they also form a line. Or if you remember, a line is also a straight angle. And if we remember our definition of what a straight angle was, or what a line is, that's 180 degrees all the time. Okay, so that's another thing that's not in that definition, because you're supposed to already know it, that a straight angle is a line, and a line has a measure of 180 degrees. Okay, but a linear pair is just two angles that are next to each other that form a straight line. So that, for some reason, that's difficult sometimes for some students to remember, understand, be able to put together. You got to have that down, so study. Okay. Complementary angles, there's two angles that add up to 90 degrees. The key term is they add up to 90 degrees. They could, be two angles that look, there's a right angle. I draw that. Well, now I got two angles and they add up to 90. It could look like that, or it could just be, two angles out here and out here. This one's, let's say, 40 degrees, and that one's 50 degrees. If I add them together, do I get 90? And I do. So now I can call them complementary. Okay. Supplementary angles, kind of the same thing. Two angles that add to 180 degrees this time. Okay, so here's an example. The linear pair that I talked about, there's two angles together, they add up to 180 degrees. They are supplementary. Okay, so they could form a line, or it could just be, I got an angle right here and I got an angle right there. This one's 50 degrees. This one's 130 degrees. Do those two add up to 180? They do. They didn't form anything, but when I add them together, I get this 180. So therefore, I can call them supplementary. Okay. So down here, there's a question: why are vertical angles congruent? It's because they're on opposite sides of the x. I kind of talked about that one a little bit. But the openings that is created by those two lines that intersect that created the x, they create congruent angles that are, in this case, opposite each other or vertical. Okay. So we'll kind of look at that and practice that a little bit. Okay. So let's do a couple things here. They want to know the measure of the other angles. If this one's 80, it's vertical with this angle over here. So vertical angles are supposed to be congruent. So this one has to be 80 degrees also. Okay. But I want you to look at something here too. I've got a straight line. I'll look at this one right here. That straight line is made up of this angle that they tell us is 80, but I got this other angle over here. Well, what should that angle measure be? Well, remember, a straight line is 180 degrees. So if I subtracted this 80 from it, that would give me this angle right here, which should be 100 degrees then. Okay? Well, that's really important topic that we get that. I can play games. I got these different vocabulary rules and names and whatnot that go together in this one picture, and I got to kind of be, understanding how I can make them work all together. And if this up here is 180, then it must be vertical to this angle down here then, because they're opposite each other. So then this one should be 100 degrees also. Okay. And I looked at this line going this way being 180. Well, that's a line too. Is it 180? Well, these two are going to give me 180. Those two are going to give me 180. These two give me 180. So you're taking these terms and kind of lumped them all together in one picture, and we got to be able to see that. Okay. All right. So let's really quickly. We kind of jumped really fast here with looking at those two things, and then kind of come into a question like this. This is algebra thrown in with those rules. The one rule, I'm going to hopefully not confuse you here, but I just want to make sure you understand something. Vertical angles are supposed to be equal. Well, that means that these two are vertical. They're opposite each other. They should be equal. And you don't need to write this down. Just kind of watch here for a second, because I'll probably erase it. If they're equal, I can set them equal. We kind of did that a little while ago with some other stuff that we did. Well, they're equal by rule, so I can set them equal to each other, but now I want to solve it for x and y, and I can't. Now, this is some calculus stuff that I need to be able to do, and we're not there yet. So how can I solve it? I can't. So if we go back to some other rules, you know, I used the vertical angle rule, and that's not going to help me. Okay, it's not going to help me here either. These two angles right here are equal, but if I set them equal, I get different variables and I can't do it. But the other rule that goes with this is I've got a straight line right here, and I know that a straight line equals 180 degrees. Let me get rid of this. And if I look at this one, if I look at this line, I'll call this the top. Those two angles have the same variable, in this case x. And I know that a line, by my rules, my definitions, that those two angles are adjacent and they should equal 180 degrees. So if I take those two angles, add them together, I should be able to solve it for x. Okay? So hopefully you got that. I try to go slow, and I try to make sure you understood why I'm doing it this way, because I have choices here, but I'm kind of limited because there was different variables in the problem. So I'm going to go ahead and solve this. 3x and 1x gives me 4x. 5 and 15 gives me 20. That equals 180. I'm going to solve it for x, so I'm going to subtract the 20. And I'll go ahead and divide by 4, and I get x is 40. Okay, so there you go. But you know, I'm not really done yet, because I still have to find y, and I probably on a test would ask you to find the measure of all the angles. So to do that, I have to go take that 40 and plug it back in, at least for x, and that's actually going to help me find y, I think, a little bit easier than what we just did. So if I take x is 40 and I go plug it back in here, I'll go to the top, the 3x plus 5. Well, 3 times 40 gives me 120. And 120 plus 5 gives me, at this angle up here is 125 degrees. Okay? And if I go down to the angle below it, so x plus 15, well, x is 40, so 40 plus 15 is 55. Okay? Now I'm going to check my work here, because remember the rule was those two angles should make a line, and the line's 180 degrees. What's 125 plus 55? Well, that gets me 180 degrees. So we did it right. We were correct in assuming I could add them together and that it made a line of 180 degrees. Okay. So now but I still have this issue. I got to still solve it for y. Now I could go back. This x plus 15 and this y plus 20, they're vertical. They're on opposite sides of the x that's created there. Hopefully you can see that now. These two are opposite, so they should be equal. Well, I just found out that this angle down here is 55 degrees. So can't I take that y plus 20 and set it equal to 55? And will that help me find y? Well, if I subtract 20, I get 35. Okay. So hopefully you followed that. And I chose that specifically. I'll explain why I did it that way in a second. But I got to check my answer here. If I take the 35 and I put it back in for y up here, that gets me 55 degrees. And this angle over here is 55. So remember, vertical angles are supposed to be equal, are they? And they are. Okay. Now, I could have done that same thing to solve for y. I could have used this angle up here is 125. I could have set it equal to 4y minus 15 equals 125 because these two angles are opposites or verticals, and they should be equal. So I could have solved it that way too. I'm a positive person, so that's why I took this y plus 20 because it's positive. I don't like this negative sign in the 4y minus 15. But if I add 15 to both sides, I'm going to get 140. I'm going to go ahead and divide both sides by 4. And I think there I also get that y is 35 degrees. So we got the same answer for y, but doing it two different ways. Okay? All right, so that's a test question right there. You should probably notate that. Make sure it's something you go back and look at a little bit more before a test. Study it each night. Make sure we got that, okay? All right. Let's do example 3 here. Key word is complementary. If we remember, that's two angles that add up to 90 degrees. So I've got angle A and angle C. Let's just write this down. A plus C has got to equal 90. Well, they tell me that A is 38, so I'm going to substitute it in for A, and I think I could solve for C pretty easily, okay? So if I subtract 38 from both sides, hopefully my math is good. I think I get 52 degrees for C. Okay. All right, next one. This is a little bit more difficult question. This is more of what you're going to get, so we got to make sure you go back to it. So put a star or whatever. This is going to be a test question. First off, the word supplementary means 180, and I can't tell you enough how many times kids get the word supplementary and complementary flipped. So you got to study it. You got to know it. Supplementary is 180. Okay. So the rule was I could take, and let me write this out. T and R. If they're supplementary, I can add them together to get 180, okay? So T is really 6x minus 1. R is really 5x minus 17. But together, they equaled 180 degrees, okay? So that's how I want to set these up. And I'll kind of let you do the math on that one. So if you want to hit pause and solve it for x, but then they want you to find T and R, so you got to go plug it back in. So if you want to hit pause and do the math, you can. Okay, so if you did all that math, x, I think x equals 18, but they want T and R, so that means I have to go plug 18 back in for x here and get the measure for each one, okay? So 6 times 18, I believe, gives me 108, but 108 minus 1 gets me 107, so angle T equals 107. If I take 18 and plug it back into, go plug it back in for x over here, I think I get x or 5 times 18 gets me 90, and 90 minus 17 gives me 73, I believe. So angle R equals 73 degrees. But checking myself, I'd want to make sure that 107 plus 73 gets me 180, and it does. Okay. All right, so that's another test question. Just got to keep our terms correct and make sure we're going right direction. All right, this one gets a little confusing. This is a test question too, so let's kind of simplify a little bit. So stick with me. First question, or first part of the question says x is supplementary to y. So let's just do this. Angle x plus angle y is supplementary, which also means it's 100. They're 180 degrees together. Okay. And then the second part says y is complementary to z. So angle y plus angle z equals 90. Okay. And I put a line up through my z, so if you know it's a z and not a 2. The military would do that a long time ago, so that when they were sending stuff to people, they didn't think a z was a 2 or a 2 was a z. Okay. So we got that. Now they tell me x is 4x and y is 2x plus 18. They want the measure of z. So if I go, I could kind of do this in a couple different ways. But I think what I need to do, if I want to find z, I got to have y. So I could go 2x plus 18 plus angle z equals 90. Okay, so did a little bit of substitution there. All right. I could also go over here. X is 4x. Angle x is 4x. Angle y is 2x plus 18. And together they were supposed to be supplementary or equal 180. Okay, so I did the little basics, set the problems up by the rules, and then I took what they gave me and I did some substitution. Okay, so I'm going to let you guys go ahead and solve that for x, and then check your work, plug it back in. They actually want to know what is measure z, so that hopefully that'll be pretty easy. I have to go plug that back in and get that. Okay. Okay, so I forgot here. Sorry, I might have misspoken here. I set this one up, but I really have a variable x and a variable z, so I really had to kind of do this supplementary one first. And I think if I got my math right, I get x is 27. Okay, so what I'd have to do then, if I want to get the measure of angle z, y was 2x plus 18. So now that I solve for x, I can go back and plug it in for x over here. Okay. And then I could do some math here. So 2 times 27 is 54. And 54 plus 18, I think that gets me 72. Okay. And then I could subtract 72 from both sides, and angle z should be 18. Okay. All right. Angle y was 72. 72 plus 18 is going to give me 90. I'd go back and check it over here too. I'd plug 27 in for x there. So let's kind of do this off to the side. 4 times 27 is going to give me 108. 2 times 27 is 54, and 54 plus 18 is 72. That should equal 180, and it does. So I'm always trying to check myself, one, because I got to do it right for you guys, but you guys should check your stuff too. That's working towards perfection. Okay. All right. These are constructions. You have to have a protractor and a ruler and a compass, and since we might not all have that, this is something I need to do with you in class, so I'm going to skip this for right now, and we'll do that later. There's also some stuff in here that we haven't really talked about that kind of jumps ahead. So I need to kind of do it with you. So we'll skip that for now. Constructions are just things you do in geometry that get pretty important for understanding some of the different terms and how they all go together. Okay. All right. There's a couple of formulas here that we need to know. One of them here is called the midpoint formula. So if you could go ahead and write that down, I'll explain that in a second. The little ones and twos up here next to the X's and Y's are just locators. They don't mean anything mathematically. They're just telling you where something is. This would be, these two up here, A and B, are points. So a point is made up of an X coordinate and a Y coordinate. So this might be X1, and this might be Y1. This is X2, and this would be Y2. Doesn't matter which one's X1 and Y1 and X2 and Y2. I could have those flip, but the ones have to come from the same point. The twos have to come from the same point. So what I'm going to do is go ahead and substitute those into this formula. So I'm going to take A and B and substitute them. My X1 was -2. The formula tells me to add them together. And my X2 comes from the other point. The X2 was 5. Okay. And it's over 2. Okay. And let's do Y really quick and set that up. Y1 is 3. And Y2 is -2. I'm still adding it. So I'm going to kind of do it right. So I get that. Okay. So let's do some math. -2 plus 5 is 3. And 3 over 2 is a reduced fraction. I can leave it like that, or I'll put it in decimal form. So I really don't care how you do it. Just know you need to be able to do it either way. So 1.5. So if we kind of stop for a second, midpoint, we did this a while ago. Midpoint is a point that's right in the middle of two segments that are going to be equal. Okay, so I talked about that a couple sections ago. The midpoint's right in the middle. All right, so what we're doing is we have an X1 and a Y1 out here, and an X2 and a Y2 out here. And what I'm trying to do is find this point, the midpoint of those two at the end. Okay, so that's what we're trying to find. Okay, 3 plus a -2 is going to get me a 1 over 2. So I could leave it like that, or I could change that to a decimal. It would be 0.5. So what I want to do is since I found a point, I want to write it as a point. So I could write it like that, or I could write it as the fractions that I got, as long as they're reduced. Okay, so either one of those answers is correct. So what that did was it got me the middle there. Okay, right. So that just finds where is the middle point between 2 points on a graph. Okay, the other formula here is called the distance formula. So if you want to go ahead and write that one down. Okay, a lot of kids this one looks scary to me. Okay, and a lot of kids go, it was too scary, so I'm just not going to do it. Well, we can't have that kind of attitude. Okay, so it's asking me for the square root. Ask me for the square root. It's telling me to square stuff. That's what the exponents are doing. But I'm still, these little 1s and 2s in here are just locators like we did. So we're going to use the same points, but now we're going to find how far apart are they. Okay, they're not necessarily on a straight number line, so I can't like count squares or spaces to get from one to the other. So I have to use some math to be able to do that. Okay, I'm still going to use the x1, y1s, the x2, y2s that we did over here on those 2 points. So we're going to go ahead and plug it into that formula and see how far apart they are. So D stands for distance, square root. Okay, my x1 was -2, and the formula is telling me now to subtract, and my x2 was 5. Okay, and then I'm going to square it. And then I'm adding it to the y value. So my y1 was 3. And my y2 is a -2. Now remember, I'm subtracting in the formula, but I'm subtracting a negative value, squaring it. So remember, this is going to change signs. Okay, so just got to be careful with your math on some of this stuff. But I'm going to tell you really quick. You're looking for distance, and a while ago we talked about distance being an absolute value. So I need to make sure that when I do all this math, I get a positive answer. Okay, if I don't get a positive answer, I did something wrong. Okay, when I'm squaring it here and here, it should always give me positive numbers. Okay, so let's just do the math together here. -2 minus 5 is going to get me a -7 squared. 3 plus 2 now is going to get me a 5 squared. Okay. And I'm doing all the steps. I know that some of you guys are really smart. You could do some of this in your head. I'm just going to tell you don't. Okay, write your stuff down. So -7 squared means -7 times -7. Well, a negative times a negative is a positive answer. So 7 times 7 is 49. 5 squared is 5 times 5, so 5 times 5 is 25. And I can add those together. So 49 plus 25, I believe, gives me 74. Okay. So the square root is 74. So this is another thing in math that we talk about later when we do some algebra review. That 74 is not what we call a perfect square. There's no number times itself that gives me 74. So I would need to stick that into my calculator and probably do that. I'm going to guesstimate it. I know that 64 is a perfect square. 8 times 8 gives me 64. And 9 times 9 gives me 81. So 74 falls in between 64 and 81. It's closer to 81, but not by much. So it's got to be like 8.6 or maybe even 8.7. If rounding, you guys tell me. I'm estimating. So the distance between these 2 points is 8.6. Okay. So that's the distance formula. How far apart are these two on a graph? Okay. All right. This is a midpoint question down here. This one gets a little bit trickier too. So let's just, I'm going to do this. Follow with me. Write it down. Get it? Draw something here so you know it. There's an endpoint R and there's a midpoint M. But there's no other point out here. They don't tell me what the other endpoint is. Okay, remember the midpoint was what's the middle point between here and here. Well, they're giving me this one and this one. Okay, but I could still use the formula. I just don't. I'm going to call this my x2 and my y2. This is going to be my x1 and my y1 because they gave it to me. Okay. This is my midpoint, okay? So they gave me the midpoint, so I kind of have to go back up here, and I'm going to do this backwards, okay? So what I'm going to do is, I've got my x1, it's -1, but I don't have my x2, okay? But it equals what the x value was for my midpoint, which in this case was 2. Remember, my midpoint's always over 2. Okay. And then let's do my y's. I have my y1. It's this guy, so 7, but I don't have my y2. And it's over 2. And it gives me the y value for my midpoint, which was 4. Okay. So if you look at this, it looks really hard, and a lot of you guys are going, how do I do this? But remember, this is a fraction that equals another fraction, and when they equal each other, I can do things called cross-canceling, or I can multiply it by whatever the denominator is. So I could multiply both sides by 2, or I could cancel them out. Okay. So I'm gonna go ahead and show you this, because a lot of kids need to know how to do this. I'm gonna multiply both sides by 2, so that allows me to cancel that out. So I'm gonna get what's left on the top, -1 plus x equals 4. I'm gonna go ahead and add 1. Okay. Here I'm gonna do the same thing. I'm gonna multiply by 2 to get rid of the fraction. And I get 7 plus y equals 8. And I'm going to subtract 7. And I get 1. Okay. So what that did was it gave me x and it gave me a y. So that creates a point, and it's the other end of my line. Okay. My board is messing up. Okay, sorry about that. So my other endpoint is 5, 1. Okay. All right, so we're gonna do a example 3 is a distance problem. So remember, we're gonna use this. Okay, so I just do this to help kids. This is my x1. This is my y1. Here's my x2 and my y2. Okay. It doesn't matter which one you call the ones and the twos. Okay, and I'll be honest with you too. When I was doing this in school 1,000 years ago, it was really written like this, and a lot of kids find that it's kind of like backwards to them, so they find it a little bit harder to do. So, in new math books, they've written like this. Order doesn't necessarily matter as long as you're doing it the same way all the time, and you should still get the same answer no matter what. Okay, so I'm going to have you hit pause and do this math example 3, and then for example 4, we'll do that one a little bit together. Okay. Okay, so plugged everything in, kind of with how we notated it to start with, just so we're all doing it the same way, okay? And I got a distance of the square root of 185. And 185 falls somewhere between 13 and 14, so 13 times 13 is 169, and 14 times 14 is 196, so that number falls in between them. And I believe it's a little bit closer to 196, so I'm going to guesstimate that it's like 13.6, because it's pretty close to being in the middle. But you guys can go ahead and stick the square root of 185 into your calculator and see if I'm kind of close, because I was just estimating. Okay, so that's how you do the distance formula. It's something that there's a lot going on, but it's math that you can do. It's really not a lot of hard math. It's just stuff you should know how to do. But there's a lot to look at and remember, and there's places to make mistakes. So just be careful. Okay. All right, we're gonna do something really fast here. It's not something we have taught you yet. You should learn this in Algebra 1, perhaps, but some of you guys might have forgot. But this is a really important topic that we need to learn, okay? And this is a kind of a classic problem. You see this a lot. So you got a ladder in a house. One thing I'm going to assume that the house is made at a 90-degree angle with the ground, okay? I'm assuming the ladder is touching the ground. I'm going to lean the ladder up against the house so that it'll touch, okay? So we're going to kind of do something like this, okay? In the problem, they tell me there's a 20-foot ladder that's resting against the house. So I'm going to label that the ladder is 20 feet long, okay? And they tell me that the ladder is 8 feet from the side of the house or the base of the house. So this little distance between the bottom of the ladder and the house is 8 feet. And they want me to find how high up is the ladder touching the house, okay? So if off to the side, what I'm going to do is here's the side of the house, here's the ladder, and this is the distance the ladder is from the house. And we assume, hopefully, that the house is built at a right angle to the ground. That's for it being structured correctly. So the ladder was 20 feet, and the distance from the ladder to the house is 8 feet, okay? And they want me to get that. I'm going to call it X. How high up is it? So what's the length of that part, okay? So this is what we would call a right triangle because there's an angle in here that's right, which means that it's 90 degrees. Okay, and there's a little formula that goes to this. I have a triangle made up of 3 sides. I got 2 of them. I need to find the third. So there's a formula called the Pythagorean theorem, and that's what it is. And typically, the angle that's across from the right angle, so I have kids draw an arrow, that's your hypotenuse, which means the longest side, and in the formula it's always C, okay? In the old books, the short side would be A and the middle leg would be B. So I'm going to call the short side 8. I'll call C, the hypotenuse is always the longest leg, so it's always across the right angle. So I put things in the right spot, do my math, and I'm going to solve it for B, okay? And 20 squared is 400, okay? So to solve it for B, I'm going to go ahead and subtract 64 from both sides. I think I get 336, okay? And now to get just B by itself, I want to take the square root of it, okay? But if I do that, I have to do it to the other side. So when I take the square root of something squared, I just get what's inside. So in this case, it's B. Okay, and then I take the square root of 336, and I'm looking at my notes here. I'm not going to estimate that. It gets me 18.3, sorry. So that's how high up the ladder will touch the house. Now, I use that 18.3 just to make sure I did this right. Remember I said that the hypotenuse has to be the longest leg, so that this one that I'm missing, the one I called X, had to be less than 20 for this to work correctly. And 18.3 is less than 20, so I think we're pretty good there, okay? All right. Okay, so this is not in your notes. We're just going to do some little practice here. We're going to do some the midpoint and the distance formula, but we also want to find slope, okay? And if you guys remember, slope is called the rise over the run. So here I could really count squares. Slope was the letter M. Some Greek guy came up with that. Maybe it's Greek for slope, I'm not sure. But it's the rise over the run. So how many do I go up? Well, I went up 4, and I went over 3, and and that would be my slope. I'm going to leave it as a fraction as long as it's reduced, okay? The midpoint, remember, the midpoint is going to be the middle point of the line that's in between these two that they gave me. Well, one of them is 0, 0, and the other one's 3, 4. Now remember, I'm going to number them or label them x1, y1, and x2, y2. Now it doesn't matter that I did it that way. I could have that flipped. It doesn't matter. I just decided to do that way. So remember, the midpoint was x1 plus x2 over 2, and y1 plus y2 over 2. Okay. The distance formula was x1, so 3 minus x2, 0, squared, plus y1, 4, minus y2, 0, squared. Okay. So I set it up for you. I'm going to let you guys pause it and let you do the math really quick. You can leave things in for midpoint in decimal form, or leave it in reduced fraction form if you want, and then get an estimate or something for the distance formula. Okay. All right. So if you want to hit pause and do that really quick. Okay, so there's the math on the midpoint. I got 3 over 2 and 2. I took the 3 over 2 and I could change it to 1.5 if I wanted to. Okay, for the distance formula, I got 9 plus 16 is the square root of 25. And 25 is a perfect square, so I get 5. That's how far apart those 2 points are. Okay, so I got the midpoint, that's 1.5, and 2, that's somewhere right about here. Okay, that's the midpoint. And then the distance between those two is 5. Okay. If you look at, this is a right triangle, and so, or right angle, so I got a right triangle, so I could use Pythagorean theorem there. That's something we kind of talk about a little bit later, right? Okay. So I'll let you guys do this one. Find the 3 things. If you want to hit pause and do that, those 3 just exactly like what we did before. Okay. Okay, so here's the solutions for what we're asking. A couple things got to be careful here, okay? So I did the rise for the slope, I did the rise over the run, but I got to look at what is the line doing as the line goes left to right. So kind of like when you read a book, what's the line doing? Well, it's going down, okay? As I go left to right, what's it doing? It's going down. So that's why I got this -6 out here, which is my rise, okay? So rise over run is going to be a -6 over +2. And that's going to reduce down to a slope of -3. Okay. For the midpoint, you know, once again, it doesn't matter what you name them. The -5,4 is my x1, y1, and the one down here, -3, -2 is my x2, y2. It doesn't matter which one I call which is which. I just really need to be careful with my math here. So, you know, doing my math, for x I get -4, for y I get +1, so that becomes my midpoint. So -4, 1 becomes this point right here. It looks like that would be the midpoint. Okay. For the distance, I had to be really careful here with all these negative numbers and stuff. Right here, that should become a positive 3, but -5 plus 3 gives me this -2. 4 minus the -2 really changes that to being plus, so that's why I got 6. Okay, so -2 squared is 4, 6 squared is 36. I add those together, I get square root of 40. 40 is not perfect, and I estimated that being about a 6.3. Okay, so there's some really good practice there for stuff that would be on a test. Just hopefully you guys do good on your homework part of it and just study for your tests. Okay. Okay. Section 8 is dealing with perimeter and circumference and area. These are just things of a geometrical figure that we need to know. Okay. So perimeter just means the outside edges of a figure. So we'll start with a square. The outside edges added together. Okay. Now, so that means, and I'll call it S. So that means for perimeter, it's really side plus side plus side plus side because it's a square, and a rule of a square is all the same. So really for the perimeter, instead of having to add those all up, I'm just going to get the perimeter equals 4 times S, since they all should be the same. Okay. For area, it's going to be side times side. Okay. But in this case, since the sides are the same, I can rewrite it as side squared. Okay, so that's really kind of up to you how you want to do that one, right? For a rectangle, the two short sides are typically called the width, and the longer sides are the length. Okay, so for the perimeter, once again, it's adding up all the sides. It could be W plus L plus L. But a little easier way to write that is just 2 times W plus 2 times L, since the length should be the same and the width should be the same. Okay. For the area, it would be just the length times the width. Okay. Okay. For a triangle, we did Pythagorean theorem last section, so I'm going to kind of use these again. For perimeter, it's just adding up all the sides. Sometimes they're the same, but sometimes they're different, so it's just adding them all up. Okay. And for the area of a triangle, it's going to be the base, what it sits on, times the height, and that's the vertical height, so I need to talk to you about that, and over 2. Okay. So a base is what it sits on. So in this case, C is what it's sitting on. But a height has to be vertical. So we have to do something like this. Okay, we have to show you that something is right. Okay, so that's what that little symbol right angle. That's going to be your height. Okay, so wherever that value is. So it's going to be base times the height, and then divide that by 2. That's in textbooks, it's written a little bit different. I like this way better. It's a lot easier to do. Okay. Okay. For a circle, the circumference is really the perimeter of a circle. So it's this outside edge. All right. So for that, it's going to be 2 times pi times r. Okay. In this case, r is a radius. So a radius is a radius is determined by the center of the circle. So some point that notates, hey, here's the center, and a line drawn out to a point on the circle. That's a radius. Okay, and I could draw a bunch of radiuses. They'd all be the same. So it doesn't matter which radius I use. Okay, pi is also a number. It's 3. I typically use 3.14. There's a pi button on your calculators that goes out to a bunch of different decimal places, and that's just to get us to be more accurate, but I usually just use 3.14. I'm going to do something a little bit different here because they tell you to leave it as pi. So I'm going to show you how to do the answer for this when we do a problem like this two different ways. Okay. So let's do these examples. Oh, sorry. Area of a circle is going to be pi radius, and I'm going to square just the radius, whatever that might be, whatever number I'm given. Okay. Let's do these examples really quick. They want me to get both the area and the perimeter of these. So let me just help you out here. If I'm assuming this is a rectangle because not all the sides are the same, so I'm assuming that's going to be 6 and that's going to be 11. Okay, so if I go back here and use that little formula, the perimeter equals 2 times the width. I'll call it 6 plus 2 times the length, and that'd be 11. Okay. So 2 times 6 is 12. 2 times 11 is 22. If I add those together, I believe I get 34. Okay. You guys can tell me if I'm wrong. Sometimes I'm going along and I don't really look at my notes or check my answers. I'm just doing it. I get a little cocky. So you can say if I did something wrong. All right. The area of a rectangle would be the length times the width, or width times the length. It doesn't matter the order. So 11 times 6 gives me 66. Typically, I would, you know, if it was inches or feet or meters, whatever, I need to notate that. But since they're not giving me anything, I'm not going to do that. Okay. All right. For the circle, this is a radius. I'm assuming that point right there is the middle of the circle. It's drawn to a point on the circle. I could draw another from that point. I could draw another line. That would also be a radius. It would also be 5. Okay, so all radiuses are going to be the same. The circumference is going to be 2 times pi times r. In this case, r is 5. Now I'm multiplying all these, okay? They told me to leave pi as pi, or the symbol. So I'm not going to touch it right now. So 2 times pi is 2 pi, and 2 pi times 5 is going to give me 10 pi. Okay? The area is going to be pi r 5 squared. Okay? And I'm only squaring r, so 5 times 5 is 25, 25 times pi is 25 pi. Okay, now that's because they told me to leave it as pi. If they wanted a real answer, they'd say round it to the nearest hundredth or whatever decimal point. So I'm going to just show you that just to make sure we know it could be done different ways. I got 10. 2 times 5 is 10 times pi. Well, I'm going to change pi to that 3.14 that we talked about. Okay. So when I multiply that actually together, I get 31.4. So that's a real number. It's some, you know, more accurate something than just 10 pi. Okay. For this one, I get 25 pi, so I'm going to change pi to 3.14, and I'm going to go ahead and multiply that out. Sorry, there's a 1 right here. Let me erase that, fix it so I don't get yelled at. Okay, so that's 25 times 3.14. And I believe that comes out to be about 78.5. Let me check. So it comes out to be about that. Okay, so that's kind of doing those. All right. For this triangle, I don't think in your notes the numbers showed up somewhere else. So if you can go ahead and label it all up to do the perimeter and the area here. So in a triangle, I'm adding up all the outside edges. So they gave me all the outside edges. This should really be pretty easy. Just adding that up. 3 is not an outside edge. Okay, so don't add that. So 8 and 10 is 18 plus 4 gives me 22. Okay. The area is going to be the base, what it sits on. So I'm assuming it sits on the 10 times the height. The height has to be vertical. They probably should have shown us that, but that dotted line is making us assume that's a vertical height. 4 is not a height, 8's not a height. Okay, so times 3 divided by 2. So don't forget that. Okay, 10 times 3 gives me 30. 30 divided by 2 gives me 15. So there's your area for that triangle. Okay. Okay. So D is a little bit more complicated. This one is a trapezoid actually, and there's actually a formula for this. What I'm going to do here is just show you something a little bit different. There is a formula. It's a little bit complicated. We get it a little bit later on, so I think I'm going to leave that for later on. What I'm going to do is I'm going to cut this into, and draw this little dotted line, and I'm going to make it at a right angle. And what I've done now is created a rectangle and a triangle. Okay. All right. So I know how to get the circumference or the perimeter of a rectangle, and I know how to get the perimeter of a triangle, but unfortunately I got a missing piece. Okay, so what I'm going to do now is this 14. When I drew this, kind of split it up. What I've done is I've created that this piece right here is 10, but this piece right here is 4. Okay, so I kind of cut it off. All right. So if this is 3 right here, then that should be 3 right there. Okay. And if this is 4, then I've got part of my triangle here, but what I'm missing is this piece. Okay. So that triangle is a right triangle. If you guys remember Pythagorean theorem, we did that a little bit ago too. This will be my C because it's across from this right angle. I could do some math here. So I'm going to go 3 squared, 4 squared. It's going to get me C squared. 3 squared is 9, not 6. 4 squared is 16, not 8. C squared, I get 25 when I add those two. And remember, that really says C times C, if you remember your exponents. I want to get just C by itself. So if I take the square root both sides, I get that little piece up here is 5. Okay. So what that's doing is helping me get the perimeter of the whole thing. Okay. So what I'm going to do is get the perimeter. I'm just adding up all the sides. So the perimeter is going to be this 3, the 10 on top. I'm going to take this 14 now. I kind of broke it up to help me get something. So that's going to be 14. And then this 5. Okay. So I'm ignoring the 4 because that's part of that 14. Okay. So that's 4 sides. It gets me the perimeter. I'm going to add those all up. And I'm going to get 3 and 10 is 13, plus 14 is 27, plus 5, 32. And they did give me a unit, so 32 centimeters. Okay. All right. So hopefully you're good there. You follow that. It's just something that will come up a lot. Break it up into pieces that you can work with. Okay. So going the same kind of thing here. To get the area by me splitting it up, I actually need to get 2 areas and then add them together. So I'm going to get the area of this rectangle that I got, and I'm going to get the area of the triangle that I got, and then go ahead and add them together. Okay. So for the rectangle, it's going to be this 10 again. So I have to go back to where I split it up. 10 times, that's the length, times the width is 3, and I get an area of the rectangle as being 30. Okay. The triangle, the base, what it sits on is that 4 that I found when I split it up, and the 3 is that height. So for that area, it's going to be 3 times 4, but remember I divide that by 2. So 3 times 4 is 12, divided by 2 is 6. I want to add these two areas together because I got really two figures. I get 36 centimeters, and I use square, I use it like that, or I write square abbreviated like that. So because they did give me units, I should label it, okay? All right, so there's some stuff there for you. Hopefully we follow that, we get lots of practice in doing those types of problems, okay? Areas of a triangle with sides of 5, 12, and 13. So remember, the area of a triangle is going to be the base times the height divided by 2. They gave me a hint here. I'm going to actually look at the hint this time. And they say Pythagoras. So that's not Pythagorean theorem, but Pythagoras is that old Greek guy that came up with this stuff. So if it's Pythagoras that came up with it, then it must be the Pythagorean theorem. Okay. Now remember, C is always the longest side. It's called the hypotenuse. So I go back. Here's the sides they gave me. 13 is the biggest side, so I'm going to call that my C. Okay. So I'm going to draw a triangle, a right triangle. I'm going to label the biggest side as being 13. And the other two sides are 5 and 12. Okay. Now, the 13 is not going to help me with the area, but it helped me draw the triangle correctly. Okay. So my base is what it sits on, and my height is always vertical. So it shows me here that I drew a right triangle, so that height is 12. I could have had it flipped. The base could have been 12, the height could have been 5. Doesn't matter. Just as long as 13 is the biggest side and it's across from the right angle. Okay, so 12 times 5, or 5 times 12 divided by 2. 12 times 5 is 60. 60 divided by 2 gives me 30. And they didn't give me units like feet or inches or whatever, so I'm just going to leave it as 30. Okay. All right. So usually on a test, if we gave you a question like that, I would tell you, hey, just use Pythagorean theorem or draw it so you've got the right thing in the right place, and then use that to help you. Okay. All right. Got a really good question here. Example 3. This will show up a lot in different ways and different concepts that we're doing. They want me to get the area of the shaded part. Okay, so that would be, if you're looking at the video, it's the purple, or if you've got your note packet, it's kind of the darker area. Okay, I've got 3 circles. I'm assuming they're all the same. I'm assuming that all of them are in a rectangle, because that's what it looks like. Okay, they didn't give me a whole lot of information, but the information they gave me is really going to help. I'm assuming that this 4 is the radius of this one circle. Okay, and like I said, I'm assuming all the circles are the same. All right, and I told you earlier too that a radius drawn in, I could draw a bunch of radiuses in a circle. They all should be the same. So that should be 4. Well, here's another radius. That should be 4. Okay. What they've now created really is, this is called a diameter. Okay. If I got 2 radiuses that create a line, that's a diameter. So that diameter is really 8. Okay. So that means that this has to be 8, and this has to be 8. And I'm assuming too that the circles are all touching each other at one specific point. Okay. So how did that help me? Well, one, it helped me that tells me the length of this rectangle's got to be 24. If I add 8 plus 8 plus 8, does not give me 24. Okay. And if I drew another 4 just vertically straight up, a radius, and I drew another one straight down, Well, isn't that also going to give me 8? So that tells me too that diameters are in the same circle are going to be the same. So that's going to be 8. Okay. So what that does is what's going to help me find the area of at least the rectangle. Okay. So remember, for a rectangle, it's the length times the width. So I'll let you guys do that. We just found the length, we just found the width. I'll let you guys go ahead and do that. And I believe that 24, sorry, times 8 would give me 192. Okay. And then the area of a circle is pi r squared. So I'm just going to tell you right now, I'm going to change pi to 3.14. Okay, so I'm going to go to 3.14. The radius of the circle, now the radius of the circle, they gave it to us, and we're assuming all the circles the same, so it's 4 squared. Okay. But how many circles do you have? And everybody say, well, I have 3, and we're assuming that they're all the same. So I'm going to, whatever I get there, I'm going to multiply it by 3. Okay, so over here, for one circle, I got an area of 50.24, but there's 3 of them, so I multiply that out, and I got 150.72. So that represents the area of all 3 circles. Okay, so I'm going to come back over here. The area of the rectangle was 192. To get this shaded part, the purple or the shaded part on your notes, I need to subtract the 2 areas, okay? So it's the area of the rectangle minus the area of the circles, and it should give me this 41.28 is the area of the shaded part, okay? Now, I could leave it like that. I might on a test say round it to the nearest 10th. So 2 is the 10th spot. So if I look at that 8, it's bigger than 5. So that means I'm going to round it to 41.3. Okay. So that's a question that you'll get a lot in different places, times. You just need to make sure you kind of get the idea there. And we had to assume some stuff too. Okay. All right, here we go. Tom hiked south for 7 kilometers, and then he turned west and hiked for 4 kilometers. Finally, he turned north and hiked 3 kilometers. How far is he from his starting location? Okay. Yikes. Well, let's make Tom. Okay. And he hiked south. Now, south is, we're going to assume that he hiked directly south, so in a straight line. So let's say he starts here. Okay. Actually, I'm going to do it over here. Let's say he starts here and he hikes south. He hiked for 7 kilometers. Okay. He then turned west. So typically west is to the left. So, and we're going to assume he hikes in a straight line again. So he hikes west for 4 kilometers. Okay, so let me stop for a second. It's really important that you draw stuff. There's a lot of these word questions we get in geometry all year long, and kids try to do it in their heads. And you got to learn how to draw this and label it up so you can see it. We're a very visual society, but sometimes we don't make the visual. Okay, and then he turns north and hikes 3 kilometers. So north is usually up. And we're going to assume he goes in a straight line again, and he goes for 3 kilometers, okay? So there's his height. How far is he from his starting location? Well, he started from here, okay? So I'm assuming how far he is this kind of dotted line that I just drew there. Not a very good one, sorry. Okay? So how am I going to do this? Well, remember I said he was walking in straight lines. So I'm assuming that when he made his turns, they were at right angles. So hopefully that makes some kind of sense. Okay. And I'm going to assume that since I got these right angles, there's something in math, and we'll learn it later, that if I did this, if this down here is a right angle and I drew this line, that this has to be a right angle. Okay. I'm going to assume this line I drew here is the same length as the line I got down here. So that should be 4. Okay. Now, if I drew this line right here, then I'm going to, and this was 7, I drew this across, then I'm going to assume if this was 3, then this had to be a 4 there. Okay. Now it doesn't look like it in my drawing because my drawing is not to scale, blah, blah, blah. But hopefully you got the math part of that at least, okay? So if I'm doing that, I could use, and that's a right angle, I could use Pythagorean theorem again to be able to do that. And this line right here that I drew from where he ended his height to where he started, I'm assuming that's going to be my C, the right triangle, okay? So hopefully you kind of follow that all right. And once again, draw it, follow it, and if you're not really sure, let's make sure you ask me and let me do it over with you again, okay? So really, I'm trying to find C. So my A is the same as my B by my picture, this 4 and this 4 right here. Okay, if this is 7, then this would have to be 3 to match this guy over here. So this has to be 4 right there, okay? So 4 squared is 16 again. 16 and 16 is 32. Remember, I want to get C all by itself, so I'm going to take the square root. So C is going to be like, I'm going to estimate that. I think it's like 5 point, I'm going to say 8. So you could do that in your calculator and just tell me if my guess was okay or not. Okay. So that's a test question again, really good. A really good question. Questions will show up again and again. All right. All right. I think last one here. Find the area of a triangle. I don't believe that we give you a piece of graph paper on this one, so you might need to kind of sketch this. So kind of if you make a graph kind of like what we got here on the video, let's label it. So 1, 4 is going to be right here. Remember, this is X, this is Y. So X is 1, Y is 4. Put a point, that's A. B is 1, 1. So that's going to be right there. And C is 7, 1. Okay. So we're going to create a triangle out of this by just connecting all the points. Okay. So if you're looking at that, I'm assuming that that is a right angle because it's straight up and down and straight left and right. So hopefully you kind of agree with me on that. I just need to find the lengths of the sides. Now you got to be careful if you're counting squares. This is going to be 3. A lot of kids will say it's 4 because that's the Y value up here, but I started at 1 there, so it's really 3. Out here, this side right here should be 6. Okay. And if I go back to the question, they just want the area of the triangle. So do I have a base, 6, and do I have a height, 3? Remember, height's got to be vertical, and this shows vertical. So I really don't need that. Okay, I might ask you to find it, but today we're not going to. All right, so I've got a base, 6. I got a height, 3. Remember, the area of a triangle is base times height, and then dividing it by 2. Okay. So 6 times 3 is 18. 18 divided by 2 is going to give me 9. There's the area of that triangle. Okay. All right. Very good. Okay. Thank you.